Morning, everyone. It's a pleasure to be here in this beautiful city and this fantastic and lovely country, China. It's a real pleasure. Thanks very much. Well, my name is Marcelo Rovai, and I would like to tell you today is that the future of artificial intelligence is not that big data centers and something very small, something that will be cost less than probably you guys will pay in your lunch today. So let's talk. But of course, there is some issues on that. We are facing what they call an AI divide. To run artificial intelligence, usually we need big machines, devices that cost hundreds, thousands of dollars, and consumes a lot of energy. And worse than that, usually billions of people are excluded in global south. Okay, in underdeveloping countries in Latin America, in Africa, parts of Asia. Okay, but the good news is there is a solution. Okay, I worked for more than 35 years as an executive, an engineer, as a vice president in multinationals like AT&T, NCR, and others. And in 2015, I took a decision. Okay, I left the corporate world, returned to the academy, became a maker, and start to write and teach people how to use artificial intelligence, how to use electronics to solve local problems, how we can help each other using electronics. Today, I'm part of a group. I'm a co-chair of a TinyML 4G and Edge AI Academia Industry Partnership from Edge AI Foundation, where we try to, with help of companies like City Studio, Arduino, companies that help us with the product, with the hardware, and we can go to several countries and send those hardware, prepare course to help people to learn about TinyML, okay? But what is that, okay? What is TinyML or Tiny Machine Learning? What is the solution I'm talking about that costs very few? I'm talking about the hardware that's very affordable, very affordable. We have here a shelf, for example, that is on a few dollars. You can have this and you can run artificial intelligence on that. Okay, I don't know if you guys know this, but it's okay. And more than that, look, we can have, besides low price, you can run, in a battery that you lost years in the field, okay? It's private and it's offline. So to be more specific here, I can tell you guys. But I'm not talking that we are replacing the big machines in data centers. What I'm talking about is a kind of ecosystem. It's complementary, okay? I have here in this side, okay, in this side to the left, we have the TinyML. We have machine learning, it's part of artificial intelligence, that can run in this device that I am showing you, very small microprocessor, or wearables like my watch here, okay? Or in the middle, we have what we call edge machine learning, like your phone or a drone or a single-board computer, okay? But what those devices has in common, everything is private, everything is local. You are connected with the internet. You can run artificial intelligence on those devices. But of course, you still have the cloud machine learning for big techs. So what we're talking here is a kind of a one ecosystem that go from very small devices to the big device, depending on the application, okay? So, in short, when I talk about TinyML, I'm talking very small devices that run with a very little memory that you can run models here. Edge machine learning is bigger, okay, like a small board computer or telephone. It's a little bit more power, a little bit more expensive, but it's still in the edge without connection. It was cloud ML when you have the big GPUs running there, okay? Okay, being specific, for example, this guy that I show you guys for the Xiao S32 SE3 is very affordable device that you can start to learn. You can use it to start to learn machine learning, making projects, making prototypes, with the vision, with audio, and now also with vibration. If you want to be more serious, you can use, for example, those new devices. For example, Grove Vision AI, that's very affordable, but you can run
really serious visual projects because you have a neural network processor here, okay? Yep. Here we have an example of edge machine learning when I have a Raspberry Pi, where I can run generative AI. You can run a type of a GPT here, you know? Or if you are prepared to go to the industry, to production, you can have, for example, jet sonoring, okay, and that is more expensive, more to use in production. But the important thing is here. You should start small, you could scale up and deploy anywhere. This is key. You can deploy anywhere. You don't need internet here, okay? And this is another point. I'm talking. I talk a lot about size or money or the cost of devices. But look, nowadays sustainability matters a lot for our planet. And for example, when we're talking about those small devices, the embedded machine learning devices, I'm talking about half of a watt. You can imagine, compare this, for example, with a GPU running in the clouds when there's hundreds of watts. So those small devices are 100 times more energy efficient than the cloud AI. So when we look to this, we are talking about local solutions, with a lot of sustainability. Well, but okay, we'll talk a lot about those theory, but where makers and the students are producing or creating things nowadays. This is a map, for example, of the group of universities that we have started work together. As I said before, with help, for example, for ICTP is a UNESCO entity in Italy, in Trieste, but Harvard School, Edge Impulse, Arduino, City Studio, Edge Foundation, we collect hardwares like that we show you before, the Shao or Arduino's devices, and we send it to universities, and we prepare courses for those students. So that's the idea, to run, and doing here, we start to having projects in Latin America, in Sudan, okay, in Asia. Let me give you an example, for example. Let me show what a couple of my students are doing now, including this weekend. The students are working to try to saving beehives in Brazil. There is a big problem with the beekeepers. They are losing more than 40% of the beehives because of the disease. One way to do that, and without disturb inside, what we are doing is collecting. Here we can have a vision of the landing area when the bees arrived here, and you can count the bees here using YOLO is a visual model. And also we have here sensors like temperature and humidity, and you can have during the day see the number of bees that you have here, the humidity, temperature. If something that usually at 4 o'clock, for example, I used to have hundreds of bees, and suddenly I don't have, something is wrong. Or the queen died, or some diseases it did something wrong for the bees. Okay, so the idea here is help the beekeepers to act before it's too late. If something happens, the behavior of the bees, they can act before lose or the disease increase or something like. Okay. Another example is another students, for example, they analyze that the great majority of one of the worst problems that we have in Brazil are heart attacks. People die by heart attack, and one of the main cause of a heart attack is atrial fibrillation. So what they did, they're using data sets from real data sets from Physionet, from Germany, from China, and they create models that can run in a ESP32. And with that, with less than $50, they develop a device that can detect atrial fibrillation, for example, in a very, very affordable way. And the important thing is, if you can do this diagnostic in an affordable way, you can save lives in remote areas when people don't have money to have big equipment, Another example that I work with Marco Zenaro and Mois from Sudan, we have, more than 700 million people die with diseases that were brought by mosquitoes. like malaria, like Aedes aegypti that bring Zika and chikungunya. I don't know if it is the same name here, but I mean a terrible, terrible, terrible disease. In fact, I and my wife got one this year in Brazil. So it's dengue. Dengue, it's get on that. But what we analyzed and the project that we did, we see that, for example, each mosquito, they let's say the frequency, how they beat the wings is different. So Aedes aegypti, for example, in that case, for example, is Aedes aegypti. You can see something like 600 hertz. Okay? The mosquito for malaria is different. So what we can do, we can train in a model that you run in a small device, very, very, very small device, like that one that you guys have in your hands, and you can select, oh, this is an Aedes aegypti. So this area is dangerous. Or we can send people to go there to try to eliminate the mosquitoes there, because I can have dengue there or malaria. Okay? So it was something that we did. Those kind of devices can run in areas in the field without internet. That's the big thing. Totally disconnected on internet. Okay? Another example is very, very quickly. For example, my students, what they did here, they developed a small box here with a shell sense here. And what they did, they could classify exercise that people were doing for physiotherapy and in academy, what exercise a person is doing and if the exercise is correct or not. It's something that also, again, help, poor areas, help people to rehabilitate when they have a problem, okay? But I'm sure that a lot of you guys here say, okay, but when I saw the title, Marcelo is supposed to talk about artificial intelligence. They talk about machine learning, something sound, etc., etc. Yeah, the new era nowadays is generative AI. Everybody would like to, to understand a picture or generate a picture or generate text, generate new things with artificial intelligence. What we call this generative AI. The good news for you guys, makers here, is that nowadays you can do this. We can run, for example, this is a set of what we call small board computers, okay? Since this is a computer, something like $40 here. It's a Orange Pi here, produced here in China. Here in China, it's a RISC-V equipment. We can run small models here, like a Llama, for example, or Gemma, or Green here from Alibaba. We can run here 1 billion parameters, 2 billion parameters, 3 billion parameters. So, of course, how big the model, a little bit more slow will be, but you can run here. That's the good thing, okay? And also you go to, of course, a Jetson Nano or a Raspberry. We are doing a lot of projects in the university using a Raspberry 5, it's a small board computer. I'm talking about from $60 to $100 here, running real projects with generative AI. I show you some examples here. For example, here it's a model. It's a Chinese model named is Moondream. Look at the interesting thing. For example, I took my Raspberry, put the Raspberry in my face, and I asked it to describe me. Oh, it started to describe. Oh, the image features a man with glasses and white bird who is wearing a colored shirt. So, yeah, etc., etc. I say, interesting. He really could interpret the image that they saw. And more than that, I asked, okay, but you said you said about a colored shirt, but what's its color? Oh, the man's shirt is white. This is running completely offline in a device less than $100. You can imagine the potential of this for people that have problems, for example, with their eyes, blind people, or in industry when you do quality control, etc. No, the possibilities are amazing. It's unbelievable. For example, those are projects that we are doing where we are what we call physical computing, connect to intelligence. This is an example that my students did. I mean, I'm taking here, for example, here I have some sensors here. I taking, for example, pressure here, humidity, temperature here, or a button. And, and the LLM here, the model, the artificial intelligence model here, will read those sensors, A user can make a question. If the temperature is over 20 degrees, turn on the yellow LED. And the LLM took the decision. Based on the language, I can ask here in Chinese, I can ask in Portuguese, I can do this in English. And when people ask, what's the temperature today? It's hot today. Doesn't matter, because that's the good thing. Even though those small models, they will understand our natural language and will act in that way. What I'm talking here is, I'm talking about sensors that connect with AI and produce actions. Those are real examples that we do. Everything that I'm talking here, okay, everything, it's, for example, you can see here, I don't worry, because the City Studio people will get this in the YouTube, the presentation, and the slides. So we have everything there. But the point is, all those material that we produced in our course at university, everything that produced to the university or in books are freely available for everyone. We think that knowledge should be free and accessible for all. Okay? So I invite you guys, if you want to start with electronics, this is a good book. It was written by Lei Feng, an engineer. Leon is an engineer here in China for Edge Impulse, and I help him with the artificial intelligence part here. This is a book that I wrote and I use with my students with a Raspberry Pi to run generative AI. And this is a book for a great friend of mine, Professor VJ. I can say the most important professor in the world in the machine learning area. And Professor VJ put together a lot of information about a lot of a theory about machine learning, artificial intelligence, you can have. And he invited me, and I wrote a lot of laboratories that you can, for example, use here a TinyML kit that we have developed together with City Studio. When you put together, besides the camera and the microphone here, we have a display, we have accelerometers, etc., to do the movement, everything in a kit. And this kit, for example, we are sending to all over the world for university, for students to learn about machine learning, okay? And in the book, you have several, all the theory about that, how to use that, okay? This is only for an example. I'm not talking about something that is not real. The world today knows that embedded machine learning, or tiny machine learning, is very important. For example, our work was in the Science magazine early this year. It's a very important magazine. And look, they start the article showing the same device that you guys are seeing in your hands, okay? So, to finish here, my message for you guys is, the future of AI is in your hands. It is not in massive data centers, but in classrooms here in Asia, on farms in Africa, in clinics in rural Latin America, in the hands of makers like you, okay? Start building today. The tools are free. The impact is limitless, okay? Here you can find me and find information here, okay? Let's build those things together, okay? You have the books here, you have my GitHub, you have our link, my email. Contact me. I would love to see or to hear about what you guys have been done, with those small devices trying to solve your solutions. So, start your journey today, okay? I left you guys with 4 steps, okay? Get hardware. Start with a SHAW, with a $15 SHAW, or a Raspberry, doesn't matter. Choose one device, Learn the basics, Take here our free courses, our material, all of that. You can use those devices, you can do real things, Build a project. Try to solve a problem in your community. And most important than all, everything that I told you today, share your knowledge. Teach others. Contribute to open source. Let's pass this away. Let's do a big movement. Let's help the world to be a better word. Thanks very much.
Thanks, Professor Marcelo. We will take 1 to 2 questions from the audience. Anybody have any questions? Nope. Okay. Thank you. Oh, sorry.
Do you happen to had a chance to use the new A1100 by Seed by any chance? The A1100. Did you experiment with that already? Not yet. Okay, sad.
I don't know what.
It's like a LoRaWAN AI thing, which has a local model on it, but it sends the data pre-made over LoRa.
Well, not specific this one, but we did a lot of projects with the devices here from Seed. It doesn't matter if you take the processing, you do in those kind of device. After that, you can, for example, connect a LoRa model, but Seed has some of the projects have the LoRa model included, but it works. It's work. I mean, it's only a...
If you know anyone, send them my way.
But again, I will be here, and you can reach me by my email. If you go to my GitHub, you can see a lot of things there. And please do it. Thank you very much.
Thank you.